Welcome to Mrs. Neller's notes for her pre-calculus class. These are the notes for section 1.8, day 2, entitled Coordinate Geometry. And today we're going to talk more about the distance formula and the midpoint formulas, and circles and graphing circles, and then how to test for symmetry. So there's a lot of calculating and a lot of detail in this section of 8.2. And when we're dealing with the distance and midpoint formulas, remember we're trying to find the distance between 2 points on the coordinate plane. So when you're dealing with the distance between those 2 points, here they have a very elaborate explanation of trying to find the distance between A and B. And the distance formula actually comes from the Pythagorean theorem. So if you took your one side of the triangle, which would be the distance between x2 and x1, and the other side of the triangle, the y2 and the y1, and you squared them, you would get the hypotenuse squared. And then you have to take the square root of that in order to get the whole length of the distance between A and B. So this is where the distance formula derives from. It's related to the Pythagorean theorem and the coordinate plane, and making a triangle between 2 points and then trying to find that hypotenuse of the triangle. So you should know the distance formula, you should have it memorized, and we're going to use it now here in example 2. It says which of the points P or Q is closer to the point A? And they give you the values for the points as well. P is 1, -2, Q is 8, 9, and A is 5, 3. So if you want to know which point is closer, we have to actually find the distance. So we have to find the distance from A to Q, and then the distance from A to P, and then whichever one is shorter will tell us which of the 2 points is closer. So it doesn't matter which one you start with. I'm just going to start with AP. So I want to find that length, and I'm going to use my distance formula to do it. So if I call A, I can call that my x2 and my y2. I can call P my x1 and my y1. So if I'm substituting into the formula here, I would have 5 minus 1, or x2 minus x1 squared, plus, and then my y's, y2 minus y1. 3 minus a -2 is going to be plus 2. And those values are both squared. And now we're basically going to use order of operations to simplify those. 5 minus 1 is 4, and 4 squared is 16. And then 3 plus 2 is 5, and 5 squared is 25. So then I get the square root of 41. And I'm just going to leave my answer like that for now. I don't have to worry about breaking down the radical or making it decimal. I'm just going to leave it the square root of 41. Because when I find the length of AQ now, I'll follow the same process. I'll get one number inside my radical, and I can easily compare just based on the radicals which one is bigger and which one is smaller. So now I'm going to find the distance from A to Q. So again, I'll call A my x2, y2, and I'll call Q my x1, y1. So I'm going to subtract my x's, so I'll have 5 minus 8 squared, and then subtract my y's, 3 minus 9 squared. And remember, it doesn't really matter which ordered pair you call x1, y1 or x2, y2. The 1s and 2s in the distance formula really just mean that order matters. So if I take 5 minus 8, I also have to do 3 minus 9. I can't do 5 minus 8 and then 9 minus 3. I can't switch the order that I'm subtracting. So back to simplifying this one. 5 minus 8, that's -3. -3 squared is going to give me a 9. 3 minus 9 is -6, and -6 squared is going to be 36. And 9 plus 36 is 45, or the square root of 45. So here I can see that my smaller value is the square root of 41, so that means P is closer to A. Thank you. Okay. And for the midpoint formula, this formula always gives students a lot of grief, and I'm not really sure why. It's meant to be a very basic formula. And really, you don't need to memorize this formula in order to understand and use the midpoint formula. Midpoint is your average. It's halfway between two things. So you're adding up your x coordinates and you're dividing by 2 because you're averaging two things. And the same for the y's. You add up the y's and you divide by 2. Now, how we apply it in this problem is a little more advanced, though. We're going to show that the quadrilateral with the vertices P, Q, R, and S is a parallelogram by proving that its two diagonals bisect each other. Now, what that means is the length of R to this center point and that center point to P has to be the same as S to the center point and then that center point to Q. That's a property of a quadrilateral, or in this case, it's a parallelogram. If a parallelogram is a parallelogram, the diagonals bisect each other. So you have to think back to your geometric roots here. So basically, we need to find that midpoint between PR and SQ. And if they have the same midpoint, then they're going to intersect or bisect each other at that same point. So let's just start with SQ. And if I want to find the midpoint, I'm going to take my ordered pair for S and Q. I'm going to take my X values and I'm going to add them up. So let's see, S was 2 and Q was 4. So 2 plus 4 divided by 2. You can do the same thing for the Y's. So that'll be 7 plus 4. So that is going to get me 6 divided by 2, which is 3. And then 11 over 2. And I'm just going to leave it 11 over 2. You could write it 5.5 if you wanted to, or 5.5. PR then, if we're going to find the midpoint for PR for that segment, again, we're going to take our x's. So 1 plus 5, and add them up and divide by 2. And then our y values for each point. So that's going to be 2 plus 9 divided by 2. So 1 plus 5 is 6 divided by 2 is 3. Oh, that's a good sign. And 9 plus 2, that's 11 over 2. Look at that. The midpoints are the same. So since they have the same midpoint, I'm going to abbreviate midpoint there, that means that we definitely have a parallelogram. So that's how we show that that shape is a parallelogram. They have the same midpoint. Okay, now for circles, we have an equation for circles. It's x minus h squared plus y minus k squared equals r squared. And the x and the y basically stay x and y in this equation. And we're going to know two pieces of information. We're going to know the center of the circle, and we're going to know the radius of the circle. So the center, they can't call the center xy, so they call it hk. I don't know why, they just picked those letters and used it for the center. So h is going to be the x value in the center, so that's how we get the x minus the h, because it's the x minus the h value, or the x value from the center. And then the y value for the center will be k, so in our formula we have y minus the y value, which is k. And then the radius is r. That should make sense that the radius is r. And we always want to square that value though, so don't leave that number unsquared. Don't put 4 squared on the right side of your equal sign. Simplify that so it says 16. Now, we also have a standard form for a circle, and that just means that you have a circle that has an origin at 0, 0. So then you'd have 0 in there for h and 0 in there for the k. So you'd have x squared plus y squared equals r squared. That's your most basic form of your equation for a circle. but you want to know this one up at the top that has the minus h and the minus k in it, because you're not always going to have a circle that has a center of 0, 0. So we have a few circle examples. So example 9 has part A. It says find an equation for the circle with a radius of 3 and a center of 2, negative 5. So basically we're just going to take this information and we're going to plug it into our equation. Okay, so we had x minus h squared plus y minus k squared equals the radius squared. That was our standard form for our circle. Okay, and in our center, the x in the center is going to be the h value, and the y in the center is going to be that k value. So we're going to have x minus 2 squared, and then y minus a negative 5 is going to be plus 5 squared. And my radius is 3. But I'm not going to leave it 3 squared. That's bad form. Good mathematicians are going to square that and set it equal to 9. Now, do you remember how to graph a circle? We want to plot our center first. And then after we plot our center, then we're going to move up 3 units and down 3 units, to the right 3 units and left 3 units. So we kind of make a little X or a little crisscross, and then we just connect those 4 points around the center as best we can in a circle. So if you had to graph it by hand, you would plot 2, negative 5 for your center, and then you would go up 3 units and plot a point, down 3 units and plot a point, go to the right 3 units and plot a point, and go to the left 3 units and plot that point. And then you plot or connect those points as best you can in a circle. I'm not going to grade you on how well your circle looks like a circle. Just make it look as much like a circle as you can. Don't make it look like a diamond or a football. Okay, now part B says find the equation of a circle that has the points P and Q as the endpoints of the diameter. So this is a little trickier now, because we don't have our 2 pieces of information. We need our center and our radius. If I'm going to write the equation of my circle, those are the 2 pieces of information that I need. They just gave me 2 points on the circle. Now they do tell us that those are the endpoints of the diameter, though. So that is helpful. That's a helpful little clue. Now, if you take the endpoints of your diameter and you find the point that is in the middle of them, so let's just say there's the endpoints of my diameter. If I find the point in the middle, what is that going to be? That's the center of my circle. So in order to find the center, I'm going to have to find the midpoint of PQ. So I need the midpoint of that diameter, PQ. So I'm going to take 1 plus 5, divide it by 2, and then 8 minus 6 divided by 2. So that's going to get me 6 divided by 2 is 3, and 8 minus 6 is going to be 2, divided by 2 should be 1. Okay, so that is the center of my circle now. So that's good. But now I have to figure out my radius. And there's actually a couple different ways that you could do this. You could find the distance between one of your endpoints of the diameter and your center. So you could find the distance from P to this center that we just found, or Q to the center that we just found, and that will get you your radius in one step. Or the other way to do it, the way that I prefer to do it, just in case you made an error with your center, is to find the whole length of your diameter, PQ, since that's what they gave us in this problem, and find that whole diameter and then just divide it by 2, and that will get you your radius. So I'm going to find now the length of PQ. And to do that, I need my distance formula. So I'm going to take my x values and subtract them, 1 minus 5 squared. And then I'm going to take my y values and subtract them. Remember, when I subtract a negative, that becomes a plus a positive. So 1 minus 5, that's negative 4. Negative 4 squared is 16. And then 8 plus 6, that's 14. And 14 squared is 196. So I have a length of 212. That's my diameter. And then to get my radius, I'm just going to divide that by 2. So the square root of 212 divided by 2 is going to be my radius. Now, when I divide that radical by 2, I don't just take 212 and divide it by 2 and leave it under a radical sign. That whole radical, the square root of 212, that's my whole numerator. Then I'm dividing that whole thing by 2. And I'm not going to simplify it right now because as I plug it into the equation for a circle and square it, it's going to work itself out. So my equation for my circle now was the x minus the h squared and y minus the k squared equals my radius squared. Remember, the h and k, those are the values from your center. So we're going to have x minus 3 squared plus y minus 1 squared equals, now here's where I'm going to substitute this whole thing in. Square root of 212 divided by 2 squared. Now your calculator can handle that, but you got to do it a step at a time. Take the square root of 212 and hit enter. Get an answer. Then divide that by 2. Hit enter. Get an answer. Then square that. And when you do that, you will get x minus 3 squared plus y minus 1 squared equals 53. So that's why you don't want to waste a bunch of time reducing down the square root of 12 divided by 2, because you're going to plug it into your calculator and square it anyway, and most of the time it's going to come out to be a nice number. Now, we can graph this as well. So we'd have to graph our center at 3, 1. And then if we were actually going to graph it with our radius, we would need a decimal for what the radius actually is. So there's 3, 1, and then basically the radius would be the square root of 53. So whatever that decimal is, you would just approximate that's how far you're going up and down and then to the left and to the right to graph your circle. And they have the points for the diameter in there as well, the 2 points that they gave us in the problem. Okay, example 10 says to find the center and the radius of this circle. Now this circle is given to us in a non-factored form. So we have to do a little work. We have to take it from this big expanded version into that nice compact equation that we've been working with, the x minus the h squared plus the y minus k squared equals the radius. So we're going to have to do a little bit of completing the square for this CTS. We're going to have to complete the square. So what I need to do is a couple things to get ready to do that. I need to group all my x terms together, and I need to group all my y terms together, and I got to get rid of that constant term. I got to move him over to the other side. So I'm going to have x squared plus 4x grouped together. And then I have my y squared minus the 10y grouped together. And then I have the negative 6 on the other side of the equation now. So now I'm going to complete the square so that I change that x squared plus 4x from a binomial into a trinomial. And that way I can factor it and have it as x plus or minus something squared. So it'll become that standard form of the circle. So now I have to take half of 4, which is 2, and square it, which is 4. So I have x squared plus 4x plus 4. And I'm going to think of that as one little group. Eventually that's going to become my x plus or minus something squared. Then I'm going to do the same thing here for the 10. I'm going to complete the square with the y squared minus the 10y. So I'm going to take half of 10, which is 5, and square it, which is 25. So I'll have my y squared minus 10y plus 25. And again, I'm going to think of those three terms together. Now I did two things to the left side of the equation. I added a 4 and I added a 25. So I have to do those to the right side of the equation as well. Okay, now I get to factor. So the factors of 4 that get me to 4 are going to be 2 and 2, x plus 2 and x plus 2. And we need to recognize that we can shortcut that and write it as x plus 2 squared. We definitely want to do that here because that's what the equation of a circle looks like. And then my factors of 25 that are going to get me to negative 10 are going to be y minus 5 and y minus 5. So that's going to be y minus 5 squared. Do you see the shape of the standard equation for a circle taking shape? And then I have to combine my terms here. The negative 6 plus 4 plus 25, that's going to be 23. So there's the equation of my circle. That's the standard form. And now that I have it as the x's squared and the y squared, those little binomials, now I can see my value for my center, the 2 and the negative 5. But now remember, in our standard form of the equation, it's x minus h. So this says x plus 2. So that means for my center, I had a negative 2 for the h value. And then it was y minus k. So that means my k value is a positive 5. So that's my center. And then my radius is going to be the square root of 23, whatever that decimal is. So you can leave it the square root of 23, or you can write it out as a decimal. If we were graphing, we would definitely want to write it out as a decimal so we would know how far of a length that radius has. Okay, so completing the square comes in handy a lot when you're dealing with circles. Okay, our last concept for today then is to talk about symmetry. You should definitely be familiar with the concept of symmetry. If you look at your face in the mirror, the left side of your face is symmetrical with the right side of the face most of the time. Okay, it's the same thing in math. We have lots of lines that we graph, and we like them to be pretty. We like them to be symmetrical. And parabolas especially have a very symmetrical shape to them. So if you kind of folded this parabola right down the middle, it'd be the same on the left as it is on the right. So we say that it's reflected about the y-axis here because that's where you could fold it to make it the same on both sides. So it's a mirror image. So we basically have a lot of different situations that we're going to be testing. Parabolas can be symmetrical with respect to the y-axis as long as they open up or down. But we can also have shapes that are symmetrical about the x-axis. And parabolas can do that too. If you have a parabola that's laying on its side, if it's opening from left to right, it can be symmetrical around the x-axis. And then you have symmetry about the origin. And the book has a really nice table that summarizes all of these three types of symmetry. And these are the types of symmetry that we're going to test for in our next example. Now, the way we test for symmetry around the x-axis is that you replace the y with a negative y, and then you solve the equation to see if you get the same thing. The way you check for symmetry about the x-axis is you replace the x with a negative x, and you solve the equation, and you see if you get the same thing. And then to test for symmetry with respect to the origin, you do both of those. You replace the x with a negative x and a y with a negative y, and you see if you get the same original equation back again when you simplify it. Now, if that happens, if you get the same equation back again, then you have symmetry. And here's some really good pictures of different types of graphs and their symmetry with respect to either the x-axis or the y-axis or the origin. The origin ones kind of look a little diagonal. Okay, so our last example then says to test the equation x equals y squared for symmetry. Now, hopefully you know that this is going to be a parabola. Hopefully you know it's going to have symmetry. It's a parabola that opens to the right, and we'll talk about that. I'll show you how to graph this in your graphing calculator in a moment, but let's use those 3 little steps that were on the previous slide for testing for each type of symmetry. So if we want to see if there's symmetry around the x-axis, we're going to take our original equation, the x equals y squared, and we're going to replace the y with a negative y and see if we get the original equation back again when we simplify. So I'll have x equals negative y squared. And when you square negative y, you get x equals y squared. So I got my original equation back again. So yes, this equation is going to have symmetry around the x-axis. But I also have to check for the other two. It could have both of them, x and y axis symmetry. It could have x-axis and origin axis. It could have y-axis and origin axis. It could have all 3. So you have to test for all 3. Now to test for symmetry around the y-axis, I'm going to replace the x in the original problem with a negative x. Now, there's not much I can do to simplify that equation. I'm not going to be able to rework it so that I get my original equation back again. So, no, there's no symmetry around the y-axis for this equation. And I do want to check for the origin, for symmetry around the origin. And this is where I replace both the x and the y with a negative x and a negative y. So I'm going to have negative x equals negative y squared. And if I simplify this, the only thing that I can do when I simplify it is square that y squared. And that's not the original equation that I started with. So again, no, there's no symmetry about the origin. And you should be able to do process of elimination here. You know that if you have one either x-axis or y-axis symmetry, but you don't have the other one, you're probably not going to get the origin. It could happen depending on the problem, but in this case, you know that here for the y-axis, when we plugged in the negative x, that got us an equation that we couldn't simplify back to the original one. So we should know that here, when we plug in that negative x, we're setting ourselves up for that same scenario again. Now the other way you can do this problem is you can actually solve for y and put it into your graphing calculator, okay? And you can actually look at the picture. So if you solve this original equation for y, you'd have to take the square root of both sides, and you end up with y equals plus or minus square root of x. So that's what you have to substitute into your graphing calculator. And in your graphing calculator, you'd want to go to y equals, and really we have 2 equations. We have y equals positive square root x and y equals a negative square root x. So you have to put both of them into the graphing calculator. And then when you graph it, you can see that you get that parabola that opens to the side, and it does wrap itself evenly around the x-axis, so there is symmetry. Now remember, in your graphing calculator though, we had to enter this into the y equals. And technically our equation was x equals y squared. So when you do your table of values, if you were actually going to graph this, remember that it kind of flip-flops. If you were going to make your actual table of values to graph it, this x column in the graphing calculator would actually be the y value that you would write down, and then these y values would be the x values that you would write down. But we'll get back to more of those details in the future. Okay, but just for now, remember that if you wanted to do this in your graphing calculator, you could solve the equations for y and plug them in and graph them and visually see if there was symmetry. But we also want to test. We have to know how to do those 3 tests for symmetry, because not every equation I'm going to give you on a quiz or a test is going to be one that's easy to put into your graphing calculator. Just a little hint. Okay, so there is your homework for this evening. Practice those problems, and if you have any questions, come on in and see me before school.